How on earth does Spotify put like over 80 million songs at your fingertips and make it feel instant?
Okay, to figure that out, we're going to break it down. We'll start with the challenge of just how massive this thing is. Then we'll look at how they actually organize their people for innovation. After that, we'll follow a song on its journey from their servers to you, break down the anatomy of what makes it so fast, and finally, see how the whole system is designed to change over time.
All right, first things first. To really get this, you have to understand the scale we're talking about here. And honestly, the numbers are just mind-boggling.
Okay, first up, you've got over 75 million active users every single month. And think about it, every single one of them expects a perfect, seamless, and lightning-fast experience every time they hit that play button.
And if that wasn't enough, the system has to manage, get this, over 2 billion playlists. That's 2 billion with a B. These are all created by users, so it's this huge, dynamic pile of personal data that has to be managed flawlessly.
And the music library itself, it's never finished. We're talking more than 20,000 new songs being uploaded every single day. The system has to take all that in, process it, and make it available instantly without ever skipping a beat.
So, you see, the main takeaway here is that from the very beginning, the architecture had to be built for this. It was never just about playing music. It was about scaling to millions, working on every phone, tablet, and computer out there, handling all these complex rules, and, staying ahead in a super competitive market. You have to be able to react and out-innovate everyone else.
So how do you even begin to build something like that? Well, here's the interesting part. Before you even touch a line of code, you have to solve the people problem. You need a human architecture that can actually innovate at that kind of speed.
And Spotify's answer to this was brilliant. Small, autonomous teams. Seriously, you can think of them like little startups living inside the main company. Each team owns its own feature, from the very first idea all the way through to deployment and keeping it running. This lets them move incredibly fast without getting tangled up in red tape.
And what this looks like in practice is you have over 90 of these teams spread across 5 different offices around the world, all working on the same product but on their own little piece of it. It means they can all move forward at the same time in parallel, which is just a huge boost for innovation.
Okay, so we've got the people and the philosophy down. Now let's get into the nitty-gritty. Let's actually follow a song on its journey, from Spotify's servers all the way to your ears.
All right, take a look at this. This diagram is basically the map of the entire system. You can see your phone or laptop up at the top. That's the client. And way down at the bottom is the master storage, where every single song lives. We're going to follow the data right through the heart of this thing.
So on the surface, it's pretty simple. Every single time you hit play, this 4-step dance kicks off. Your app connects to the mothership, it gets pointed in the right direction, it grabs some info about the song, and only then, as the last step, does it actually fetch the music itself.
So that first connection, it goes to what's called an access point. The best way to think about this is like it's Spotify's bouncer and front desk all rolled into one. It checks who you are, figures out where your request needs to go, and makes sure the system doesn't get swamped with traffic. And it does all of this over one single, secure connection.
Okay, so once you're past the bouncer, your request gets sent to one of almost 100 different backend services. And this is where that team structure we talked about really comes to life in the code. There's no single giant Spotify program. Instead, there's a little service that just handles search, another one that just does playlists, another for artist info, each one doing one thing and doing it incredibly well. It's the classic Unix philosophy.
Okay, we have the blueprint. We see the path. But now let's get to the really cool part, the speed. How does it feel so instant? How do they get from your finger tapping the screen to music in your ears in what feels like 0 time?
Well, it all starts with a single goal, a really, really ambitious one. For their storage system, the target is to serve the huge majority of song requests in under 50 milliseconds. To put that in perspective, that is literally faster than you can blink.
So how in the world do they hit that number? This is where it gets really clever. Check this out. Half the time, a full 50% of the time you press play, that song is already on your device. It's sitting in a local cache from the last time you listened. It's genius, because the fastest network request you can make is, well, no request at all.
Okay, so what about the other half of the time? For everything else, Spotify has this really smart 2-layer storage system. All the popular stuff, the tracks that are trending right now, they live on these super fast, high-performance servers called production storage. Then the entire rest of the massive 80 million song catalog, that lives in a slightly slower, but absolutely enormous, master storage. This setup guarantees that the songs people want most are always served up at top speed.
But you know, a truly great system isn't just about being fast today. It's about being able to adapt. And this is a huge part of thinking from first principles. The perfect solution for 2008 might be the wrong solution for today.
And you can see this perfectly in Spotify's own history. When they first launched back in 2008, they used a really clever trick to save money on servers, peer-to-peer, or P2P. This basically meant that listeners' computers would share song data with each other, and it worked. By 2011, a whopping 80% of all their music was being delivered this way. But as the company got bigger and the internet itself got faster, the P2P approach started to cause more problems than it solved.
So what did they do? In 2014, they made a huge pivot. They moved away from P2P entirely and invested heavily in their own powerful, centralized servers. This move just perfectly illustrates that core idea. The architecture was never set in stone. It was designed from the ground up to evolve so they could react to new challenges instead of being stuck with old technology.
And that really leaves us with this one final thought. An architecture that's built on first principles is never really done. It's more like a living thing, always ready for what's next. As our demands for streaming grow, as new technologies pop up, the fundamental problem stays the same. How do you make millions of songs available to millions of people instantly? The only real question is, what will the next evolution look like?